Before we start working on the SQL queries, so we use another class to look at the basic knowledge. So today mainly about SQL data. B.1, numeric and string data. So I mentioned, in module 1, I mentioned a little bit. So today we will learn more details. All right. First, let's look at the numeric data type. So there are several numeric data types, but two types. One the integer type, another floating point. These two types, numeric data. So the integer part, there are a few types. Even the integer, you can use the whole word integer or int. Actually, most people use int. Because in many programming languages we use int, so we are used to that int. And a small int. Because when you use integer, you may use integer of different sizes, right? So in our programming languages, we have short integer, right? And we have integer and a long integer. We have several integer types. And in SQL, we do not use those short, long, we do not use. So there is a small integer type, the number of digits, relatively small. But actually, most people use the int with parentheses. Inside parentheses, you specify number of digits. So the integer size you want to use here, 2 digits. In that way, you specify the size. So you do not use the special integer name for the size. So you can specify the number of digits. 10 digits, 12, 20 digits. If you want to use for integer, you can declare in your data type. So it's different from our usual programming language. In our programming language, we cannot declare number of integer size, right? You cannot. You have to use, those given built-in integer types. All right. And another thing in this example, you can see, it's very common that people use lowercase int. Although if you use capital int, it's okay. Int is a keyword. We know keyword by convention. People like to use capital. That's the convention, not required. But for the integer type and for some data types, many people, it's very common, many people use lower case. The default keyword here you can see capital default. But integer int and then later for the string type, it's very common. You see people use lower case. All right. So that's integer. Another floating point numbers. And all real numbers. But in computer, so here, the concept floating point. Here we are using the computer science environment. So you need to know in computer science, when we represent floating point numbers, it's slightly different from our math. In math, we have real numbers. The concept slightly different from the real number concept in math. Because the main difference is in math, when we talk about real numbers, the number after the decimal point, any number of digits, we don't worry. Yeah. Even infinitely many digits after decimal point, we can still take it because it exists. That number exists in math. But in our computer science, your computer hardware can only represent limited number of digits. So that's different for math. Math, we don't worry about the number of digits. Yeah. Infinite number, it's still a valid number in math. But in our computer science, no. Our computer can only represent certain number of digits after the decimal point. After that, the computer has to do the truncation. Yeah. So then there is a truncation error caused due to the hardware limitation, right? Yeah, hardware. Yeah. Truncation error we need to consider. Yeah. So later I will talk about this concept again. Yeah. All right. Yeah. So here you can see these three different ways. Yeah. Yeah. Actually, yes. Three. Here you can use the float keyword. You can use the real keyword. You can use double precision keyword, right? Yeah. But there is another one, decimal. Decimal. Yeah. You can use to specify formatted numbers, yeah, or DEC for short. Yeah. DEC means decimal. Okay. Yeah. DEC parenthesis, you provide two parameters, I and J, because you want to tell the DBMS more information. So what's the meaning? Yeah. Or numeric, I, comma J. Yeah. The meaning is I parameter precision. Yeah. Its meaning is the total number of decimal digits. Yeah. Yeah, so here the total, yeah, actually, yeah, based on our real world experience, when we say I, total number of digits, yeah, before and after decimal point. Yeah. So actually this I means, yeah, before adding together, before and after. Yeah. When we use I, okay? Yeah. Digits number before decimal point, after decimal point, adding together. That's the I. Yeah. Then J, the number only after. Okay, J is the number of digits after, yeah. Not before. Okay. Yeah. All right. Yeah. So when you use this I, J, two parameters, you can also use, for float. For example, float, yeah, sometimes people use lowercase. It's very common. Yeah. For example, 4, 2. Yeah. When I want to represent float point number. So before digits, decimal point, and after decimal point, adding together, total 4. The second parameter 2 tells the DBMS after the decimal point there are 2 digits. Before 2, after 2, adding together 4. Yeah. So for floating point, float, real, double, you can use IJ way. Okay? Yeah. All right. But here, now I need to talk about the truncation error. So I mentioned that truncation error. Yeah. So here there is a potential problem related to the truncation error. Yeah. So I want to explain this background knowledge, because in the real world, sometimes you may encounter this problem. Yeah. So if you have the background knowledge of this, then you know what's going on. Yeah. So you will not feel, panic. Yeah. Yeah. All right. So regarding the truncation error, the reason, I said before, because the computer hardware can only represent certain number of digits after the decimal point. Yeah. Usually 10 something. Okay. Usually 10 something. Yeah. 12, 13, 14. Yeah. So close to that range. That many digits. If more than that, then truncation. Yeah. All right. Because that error looks very little, right? So small. Yeah. So let me use 12 digits after decimal point. That small. So you may feel if we do truncation after that 12 digits, then in most of our real world applications, we won't have any problem, right? Yeah, it looks like that. Yeah. But it may cause some, because in the real world, although each number after the truncation you do not lose much, so very tiny, because smaller than 1/1000th, right? 1/1000th is 9 digits after decimal point. Here 12 digits. See, 1/1000th, smaller than 1/1000th. So you may feel no big deal, but after accumulation, that could be a significant number. Yeah. All right. For example, think about in banking industry, because you need to process large amount of money for a long period of time. Think about if there is accumulate the tiny part, the truncation, little, eventually that amount could be, relatively large number. If you see that difference, you know where it comes from. Yeah. All right. So here, in banking industry, we need to be very careful. Because it may cause, due to the accumulation, the amount could be some number you cannot ignore. Yeah. After some time, accumulation, you may not be, you want to ignore, right? Yeah. So here, but there is another related error caused by the binary. So here, although you see the decimal, right, the decimal system, because in everyday life we use in our human life we use decimal numbers, right? We do not use binary numbers in our everyday life applications, but in computers, the binary system is used. Then there is a conversion between decimal and the binary conversion. Decimal. So here, although you see the decimal, but the internal inside computer, the internal representation must be a binary representation, right? So then there is a conversion problem. For the when you do the conversion between these two systems, there is a potential error, potential, the error related to precision error. Yeah. Okay. Due to precision. Yeah. So this error is different from that truncation error. Yeah. Different from. This error is due to the conversion between different numeral systems. These two numeral systems, decimal numeral system and the binary numeral system. You need to do conversion. Yeah. Here, I want to give you a simple example. All right. Yeah. Look at when we have a number, one half number, if you want to represent in a binary system, you represent 0.1, right? In binary system, yeah. First, it's less than 1. So 0, integer part is 0, then you have that binary point. After that binary point, you have first bit, yeah, here we do not call, yeah, the binary digit, so it's a bit, yeah. First bit is 1, 0.1, that is, our usual 1/2, okay? All right, our usual 1/4 in the binary system, 0.01, okay? Yeah, so you get the idea, okay? A power of 2. Yeah, so here you see, if we represent fraction 1 over power of 2, 8, yeah, then we can represent the binary representation easily. Yeah. But there is a problem. Yeah. If we want to represent a fraction that is not power of 2, let's say 1/3. How do you represent 1/3 as binary representation inside computer? Because this time your denominator is not power of 2, then after the decimal point, you need to have infinite many bits if you do a conversion. Yeah? Infinite many bits conversion. Yeah. Then, but the computer, you have to do truncation, right? After the truncation, then you have some error. Okay? Yeah. So this error, actually, the reason of the error, 2 factors cause this error. One is the conversion between different numeral systems. Second, truncation. Yeah. Because eventually you need to do the truncation. Yeah. In that way, you can see when you use the decimal data types representing numbers in the real world applications, and you need to process large amount, many numbers in accumulated way. So after long time, you may have accumulated number that you cannot ignore. Okay? Yeah. Just be aware of that problem. Yeah. So yeah. Then you need to, find a way to solve the problem. Yeah. Based on the real world situation. Okay? All right, yeah, so here, the background about this numeric data type. Yeah. Character string data type. Yeah. So these two data are most commonly used. Yeah. Most of our data in these two types, the string type. The string type is slightly different. So we have fixed length. Yeah. After you declare, then the length, fixed length. Okay, yeah. Character, yeah. CHAR parenthesis N, so you specify number of characters. Yeah, so these two ways, character, parenthesis N. Yeah. When you use the fixed character data type, yeah, sometimes your data may not occupy all the positions you declare. Yeah. So then, blank character, space characters is used to pack the unoccupied positions. Yeah. All right. Yeah. All right. So that is for the fixed length, you need to be aware of that. Okay? Packing the blank characters, space characters. All right. Varying length, that's different. Yeah, varying length, you do not pack. Okay, you do not pack, not like fixed. Yeah, because not fixed. Sometimes you use more characters. Sometimes you use fewer characters. Yeah, yeah. Varchar, VARCHAR, variable. Yeah, varchar. Yeah, parenthesis of n. Yeah, or some other ways, but this is the most commonly used. Yeah, because shorter, yeah. Easier, shorter. Yeah. All right. N is the maximum number of characters. Yeah. Maximum. Yeah. Yeah. Fewer than that number, then you do not pack. Yeah. That's different. Yeah. Yeah. Fewer, then it uses fewer space. Yeah. Yeah. DBMS does not need to use all the positions up to the maximum. Yeah. Yeah. Fixed, then it uses all the positions. Right? If you do not have all the positions occupied, then space characters, pack it. Yeah. All right. Here, example here. If we have a content field, yeah, so here we're talking about in math question bank example. Yeah. So here we're talking about, so this is from math question bank example, the background. In that example, we need to create a table called a problem table. Yeah. In the problem table, we need a field, the content of the problem, right? Yeah. We need to store the content of the problem. Yeah. So when we declare the content of the problem table, so we estimate. So we feel if we use up to 3,000 characters, that should be enough for our problem description. Yeah, so that number, 3,000 characters, should be long enough. So you need to estimate. Yeah. So based on your real world, experience, when you design your database, you need to estimate. Yeah. But in case there is a long problem, uses more than 3,000 characters, what will happen? Okay, that is possible. Sometimes, yeah, there is a math problem extremely long. Yeah, although it's rare, right? Yeah, such a long problem, it's rare. Yeah, because it makes students very hard to understand the long problem, right? Too long. Yeah, it's rare, but there is a small possibility it could happen. So if a problem has more than 3,000 characters, what would happen? No. There are some possibilities, so you can imagine. Yeah. Is it? So when you enter such a long math problem, will you get a rejection from the DBMS, or the problem is accepted, but the part after 3,000 characters will be truncated? Truncated, okay? Yeah. The second one would happen, okay? Yeah. So more than 300, then truncation. Yeah. There is a truncation after 3,000 characters. Okay? Yeah. No error, no warning, no error. Yeah. But you may lose some part of the content. Yeah. So in your database design, you need to be aware of this situation. Okay? So that means because in your design, you have to use appropriate number, right? You cannot leave it blank, right? You have to provide a concrete number there. But your concrete number, you do not want to use too large, right? Yeah. Too large, Yeah. So you may feel you waste a lot of space. Yeah, actually, you won't waste space. Yeah. Up to that maximum number of characters, if you do not use that many, then the DBMS will shrink. It will reduce the storage space. Yeah. So there is a way in DBMS. Yeah. So you do not use that much space. Yeah. But still, people may not like to use a too big number, just the appropriate number. But you need to be aware. So if the content, your data content, is longer than the data size you declared, then you may lose part of the data. So based on this understanding, so in your application program, probably you may want to check the data size, right? If you want to have at least a warning, right? You may like to have at least some warning, some message. Yeah. So there is a problem here. Yeah. So you need to find a solution. So this problem, you need to consider a better way to solve this problem, because you don't want to lose any data, right? You don't want to lose any data. Okay? Yeah. All right. Yeah. So here, let me, because this, another question related to this fixed length. Yeah. Later we will talk about that. Yeah, but here I just because we are here, so let me just say something about it. Yeah. Fixed length. If we do not use that many characters, then we need to pack space characters. But when we pack, there are two cases we can pack, right? Yeah. So think about Suppose n equals 6, okay? N equals 6, but we only use 2 characters, for example. Yeah. So we only use 2 characters. Then we need to pack 4 space characters. But from left, pack 4 space characters at the left-hand side of the 2 characters or right-hand side, right? There are 2 different ways you can do. Yeah. So, which is the correct way? Okay. One way, pack at the left-hand side. Another way, 2 characters, 4 characters at the right-hand side. Yeah. The answer is right-hand side. Yeah. Packing 4 space characters on the right-hand side, not left-hand side. Why? The reason is very simple. Okay, the reason very simple. When we have string data, sometimes we need to do sorting, right? We need to sort based on this field. Okay, we need to do sorting sometimes. Yeah. We need to think about when we do sorting, how do we order the rows in a table based on this field? Yeah. Sorting based on this field. Do sorting. Okay? Ascending, descending. Yeah. You need to do sorting. When we do sorting, we take alphabet order. Alphabetic order. We need to take alphabetic order. Okay? Yeah. Or we call dictionary order. Yeah. Alphabetic order, dictionary order. If you pack at the left-hand side, you change the order, right? Yeah. You change the order, you split. But if you pack at the right-hand side, then you minimize the impact of the order. Yeah, because when we do alphabetic order, we start from the leftmost character. We do comparison, right? Yeah, we start from leftmost. Okay, then next. Okay, so if you pack from the right-hand side, you minimize the impact of those blank space characters. Okay, because you place those blank space characters at the least significant positions, not the most significant position. If you pack at the left-hand side, you pack at the most significant positions, then the impact is too big, right? Yeah. So based on this understanding, so you can figure out so left-hand side or right-hand side. Yeah. So this problem. Okay. All right. Yeah. B.2, understand the null value. Yeah. So this is another important concept, a special data value in SQL. Yeah. So we need to spend some time to understand this null value well in SQL. Yeah. It's different from in Java, in C++. You may have some experience using the null value, right? So typically, an object, before you instantiate an object, so your object takes this null value. So in our SQL, the meaning is quite different. The understanding of this special null value is quite different from our object-oriented programming null value. Yeah. All right, what is the null value? In the real world situations, we have some, so we need to consider in our business, we may have some special situations we need to address. We need to use some special value to address those situations. Yeah. Yeah. So here, this null value is a special one that is used represent missing value. Yeah. Think about it. When the data is entered, sometimes for some fields, you may not have values. The value missing. Yeah. The value, it may need some time to acquire those values. Before you find those values, you want to enter current known values. Yeah. So let's say in this way. Yeah. Because when you enter one data entry, all right, you need to type several pieces of data items, several pieces. Yeah. But some of them unknown, missing. Yeah. You do not know. Yeah. Some of them unknown, some of them known. Yeah. Yeah. So what do you want to do? You want to enter those known values first. Yeah. But in order to make the whole data entry input successful, you need to put some temporary values for the unknown data pieces, right? Unknown data pieces. Yeah. You need to put some special values. Yeah. It's unknown. So in this situation, this null value is a good choice. Is a good choice. Yeah. Yeah. Missing. Yeah. All right. So then, but after you enter this null value, in your database, you will see capital NULL. Yeah. So in that field, you will see this capital NULL. And in italic. Yeah. So the font is italic. Yeah. Yeah. Because it does not want people to treat this as a normal value. So when you see this italic, yeah, because in the DBMS it was italic. So it tells you it's not a normal value, okay? Not a normal value. Try to make you aware of it, okay? Yeah, this one is different from other normal values. Yeah. This is not normal, okay? Yeah, all right. But there are several meanings. Yeah. To be more specific, then, when you see a null value, then there are several possible different meanings. Yeah. Sometimes you need to distinguish among those different meanings. Yeah. So one is unknown value, exists, but not known. Yeah. Yeah. For example, the first name of one person, yeah, but when we collect, we only collect the last name. We didn't collect the first name. So it's missing. So we need to, make more effort to collect the first name. Yeah. But we don't want to leave it blank, all right? We want to put a special value in the first name to make people aware of it, okay? You need to collect the first name sooner or later, okay? Yeah. So that's the situation, exists, but not known. Yeah. So you use the null value, okay? That's first meaning. Second, unavailable or withheld value exists, but is purposely withheld. Yeah. Yeah. So it exists. Yeah. But you do not want to show ordinary people that special value. Okay? Yeah. Sometimes you may need you want to hide it. Okay? You want to hide it. Okay? Yeah. Yeah. Then, but it's a special one, okay? So you have a special meaning, yeah. So you can put that null value, all right? And because you do not want to store it in this place, you want to store that secret value in a highly protected place, okay? Highly protected place. Yeah, that could happen. right? Yeah, yeah, withheld, yeah, withheld. For some reason, you do not know the reason, okay? There could be many different reasons, yeah. All right. Another one, not applicable attribute. Yeah, that's also sometimes, yeah, this field, yeah, the value for this particular person or product, yeah, you know, the value not applicable, right? Not applicable, yeah, that also could happen, yeah. And so you want to show the people the difference. Yeah. So you can also use the null value. Yeah. Yeah. And definitely you may have more than these three meanings here. Yeah. Three, just typical three meanings. But from your business, you may have more different meanings, right? Yeah. Yeah. So based on your business, yeah. So what's the specific meaning? Yeah. You need to, based on the understanding of your business. Yeah. All right. And why use null value instead of some special value? That's here. I want to explain. Yeah, I already mentioned a little bit, but I want to emphasize this point here. Yeah. Why use null value instead of some special value? Because sometimes we can use a special value. So if the value is missing, we can use a special value, right? So what kind of special value? Yeah. For a string value, yeah, because people can use a pair of quotes around nothing, yeah? Empty. Yeah. Yeah. So this week, it's an empty string. Why we cannot use empty string if we do not know the value? Why we cannot use empty string? Yeah. Actually, you can, but you need to know the difference between empty string and null value. Yeah, that's important. Yeah. Empty string and a null value. Okay? Yeah. All right. The difference is significant. Yeah. Because the empty string, this empty string, it is a normal value. Normal value. Okay? The normal value means the DBMS does not treat it differently with other normal values. Normal, because it's normal. So no warning, no signal to make you aware of it. Yeah, because it's normal. Nothing to worry about, right? Yeah. But null value, it's not a normal value, okay? So the DBMS will send you some mild warning sign. It's not a strong warning sign, okay? Yeah. So weak, mild warning sign. Yeah. Make you aware of it. Because its behavior, the behavior of null value is different from other null values. Behavior. When you do the query, it's different. Yeah. So the null value is treated differently from other normal values. Yeah. So DBMS treats the null value differently from the normal values. Normal values this different way, actually you can treat it as a warning, okay? Certain warning. Yeah. Remind you, you need to fix, there is a potential problem here. You need to fix this null value. Whenever you see this null value, you need to fix the value sooner or later, okay? Yeah. You need to fix it. But if you have a normal, you do not need to fix, right? If you put a normal value, so DBMS does not know, you need to do some more work here, right? Yeah. That could be the final value, okay? So you don't need to do any more work. Yeah. But when you have a null value, the DBMS, every time when you do a query related to this field value, DBMS would remind you, you need to do some work to fix the null value at this place. That's the difference, okay? So that's the main purpose. You use the null value, okay? Yeah. Other than that, if you don't worry about that potential problem, then you can use a normal value, okay? Yeah? All right, yeah. But the consequence, since a special null value is used, then there are several consequences due to this special value. So we will study those consequences. Yeah. All right, so make users aware of it. Yeah. The DBMS treats it different, right? Yeah. So the behavior is different. Okay, and the queries, some queries are designed for the null value in a special way. Yeah. So you will see it. Yeah. All right. Handling null values in DBMS. Yeah. Who determines the meaning? Yeah. So when you see null, what's the exact meaning of that null value, right? Yeah. So who determines the meaning of that null value? Yeah. Not SQL. Yeah. This SQL, this language cannot tell what's the specific meaning you use in your data. If you see a null value, it cannot tell you any information, any specific meaning. Yeah. Right. Not DBMS. DBMS cannot tell you what's the specific meaning, okay? Yeah. Because that meaning is related to the business, your business. Yeah. So people who are familiar with the business rules can tell what's the specific meanings of the null value, okay? Yeah. So so you need to, so you probably sometimes, you as programmers, you may not know because you may not familiar with the business rules, right? Yeah. So you need to communicate with the business people. Yeah. So what's the specific meaning here? Yeah. All right. All right. Different individual null values. Then now there is a problem. Because when you enter your data, this null value is allowed. Multiple data entries may, for this particular field, they may have null values. Yeah. So here we have, suppose there is a table, okay? Table, you have multiple rows. Yeah. Multiple rows. Now we look at one particular field. Yeah. For one particular field, null, here null, here null, right? Yeah. But sometimes you need to do comparison between different rows, yeah, with respect to this field. Okay, yeah, sometimes we need to do comparisons. But it's possible when you do comparisons, you compare two null values, right? Is it possible you compare two null values? Yeah. So here, different individual null values. What's that? So here, they want to. So in SQL, in your DBMS, when you compare two values for the same field, and they happen to be both null value, both equal null, okay? When you do comparison, what's the right way for the comparison result? Right? Yeah. So here, let me give you the rule, okay? The DBMS takes this rule when they do comparison. What's the rule? Each individual null value is considered to be different from every other null value by DBMS. This is the rule DBMS takes. Yeah, let me explain why it takes this. Yeah. So two individual null values, they are treated as two different values, not the same. So on face, you see they look the same, right? Both spelling NULL, but the DBMS treat those two values as two different values. Can you understand why? Yeah. The logic is simple, because those two null values will be eventually resolved, right? Yeah. By some future work, people need to do some work to provide their real values. If later those two null values are resolved, then it's highly likely they are different, right? Yeah. Or the possibility for those two values to be different is pretty high, right? Pretty significant. Yeah. Yeah. If the possibility to be different, if it's not a zero, then DBMS will treat them as two different values. Okay? Yeah? Because they could be different. Actually, very likely, they are different. All right? Yeah? So if it's unknown, DBMS treat them as two different values. All right? That's the special property of the null value. Okay, all right. Yeah. Then the comparison logic is different. Okay? When you do comparison, yeah, two null values on face, you see they look the same, but the comparison result will be different. So what's that? Because if you use the equal sign for comparison, you won't get true. Okay? If you compare, yeah, because there is a comparison character, equal comparison. Okay? So if you so suppose you use null equal null, so this is a Boolean expression. This is a Boolean expression. Okay? Yeah. So this expression takes the Boolean value. Boolean value, yeah. But this Boolean value, not true. You won't get a true value, okay? You won't get a true value. No. Because they are not treated as the same value. So you won't get a true Boolean value, okay? Yeah. Yeah. So we have another topic we'll talk about the Boolean values. Yeah. Here. So that's the meaning. But how do you select those rows with null value? Here there is an is operator. Okay? You can, if you use equal, then you won't get true, right? So you won't get true. So you don't want to use that equal to select all the rows with null value So you will use this is operator. Yeah. Is operator. So that's different from equal. Okay? This special is operator allows you to select all the rows for which they take the null value on this particular field. That's a special way to handle the null values in DBMS. Yeah. All right. Yeah. B.3, other data types. Yeah. All right. No language. Yeah. So here, the title is different. Probably I forgot to change the title. Yeah. All right. Boolean data type first. Yeah. The Boolean data type is different from our usual programming language Boolean values. In our usual programming languages, Boolean value will only have true and false, two values, right? But here, three value logic. True, false, and there is unknown. Unknown. A special Boolean value. The third Boolean value, unknown. So in SQL, when you write a Boolean expression, you need to consider this unknown case. You have true case, false case. Yeah. So here you can see in the previous slide, I didn't write false because when you compare two null values, it's not true. Other than false, there is an unknown case. So that's the reason I didn't write the false. Yeah. Because it could be unknown value. When you do comparison involving null value, you may get an unknown value. You may get an unknown value. Okay? Yeah. So we will see the details. Yeah. So here, just let you know the special consideration here. Yeah. All right. Because of the presence of the null value. Yeah. When the null value is involved, then you may have. Yeah. So here, I do not say you always. Sometimes you may need to use the unknown value. Yeah. Later, we will talk about that. So we will see some examples related to the unknown Boolean value. All right. Then data type, date data type. Yeah, you need to represent the date. Yeah. So the SQL standard, yeah, because the SQL is the standard used by the whole world. Okay? Not just by one particular country. We know the data format for different countries are different, right? Yeah. So in so many countries in the world, if you look at the date representation in different countries, quite different. There are several different formats used in the whole world. But SQL has to determine one fixed date format used by all the countries in the world. Yeah. So SQL takes this format. Yeah. Why? So the first 4 characters for the year number. Okay. Then dash 2 characters, 2 digits, yeah, characters for the month number. Then dash 2 characters for the day number. Yeah. This is the standard SQL format. Okay? Yeah. Yeah. So for all the countries you have to use this format. Okay? Yeah. If you use the wrong format, your data cannot be accepted by the DBMS. Okay? Yeah. So you have to follow this standard. Yeah. All right. Then time data type, time, use colon to separate different parts. Hour part, minute part, and the second part, okay, colon to separate. But there is another, because it's very common, some applications, they need to store both date and time information in one field. So one special format is created called a date time format. It contains both pieces of information, date part and the time part. So the format is like this. There is a space to separate date information and time information. Space in the middle separating them. Space character. All right. So that's pretty straightforward. You need to get used to it. All right. But one little thing I may like you know. So this is the standard format. But, so here we say the standard is like this. But the DBMS allows you, when you enter the date information, it allows some small variation. So what I mean here is, for example, let me use one simple example. So if we enter a date field in this way, 2024 dash, so let's say September, right? September, because here MM, you should use the standard, should be 09, right? September 09, But most of the DBMS, because people usually just use one digit, 9, to represent September, okay? So some people may not use 09, right? It's very common, people just use 9 here, right? So then, if for September 8th, sometimes people do not use 2-digit representation. People just use 1-digit representation. 8th, like this, okay? The DBMS does not reject it, okay? Because although it does not follow the standard exactly, but very close to the standard, right? So in this situation, the DBMS does the conversion for you automatically, okay? So auto conversion. So you will see the data entered will be standard. Okay? Standard. So no error, okay? No warning, no error. So it's a legal input. All right. B.4, compare values. All right. The equal comparison. Here you can see in SQL we do not use double equal. In our programming language, when we compare two values, we use double equal comparison operator, right? In SQL, single. In SQL, because in programming language, single equal we use it for the meaning assignment, right? Assignment. But in SQL, single equal, we use it as comparison operator. Check if the values of both sides equal or not. All right. So that comparison for exact match. Exact or not exact, only two cases. Exact match. And no order for the comparison field is required. So here, that we know for a data piece, for a data piece, when you do comparison, sometimes the order may be involved, right? Order, greater than, less than, order may be involved. Yeah. Here, when we use the equal sign for comparison, we do not require the data field has any order. Yeah. Because for exactness, we don't care about the order information. Okay, just we want to get a match or not match these two possibilities. Yeah. Yeah. So here, order is not important. Yeah. Because sometimes for some data field, the order may not be defined. That's possible. Okay, the order may not be defined. So I will talk about this order thing later. Yeah, later. Yeah. Yeah. Because although we know most of the time for our data field, there is an order. Yeah. But for some very rare situation, order may not be available. Yeah. All right. So without order definition for the field, we can still use equal sign to do comparison. Yeah. All right. Then the less than sign, greater than sign comparison, then order is needed. Okay, to get the order information between two values. Yeah. Thus, when you use these two comparison operators, order must be defined. Yeah. We don't worry, most of the time, our data field order is defined. Yeah. Yeah. All right. Yeah. So that's the general comparison. Okay, general comparison. Yeah. Then compare values for individual data types. Oh, yeah. Let me see. Yeah. Just 2 more minutes. Okay. Numerical data types. Yeah. When we compare numerical data types, there is a numeric value order, right? Yeah, greater than, less than. There is numerical data order. Yeah. For character string data type, when you compare two string values, you use the alphabetic order, or we also call dictionary order. Okay? Yeah, dictionary. Yeah. You compare the leftmost character first. If they are the same, then you compare the second left, and so on. That's the dictionary, alphabetic. Dictionary order comparison, alphabetic order comparison, and the numerical value comparison, they're different. Yeah, yeah, yeah. Today we do not have, we run out of time. Yeah, so we couldn't specify what's the difference. Yeah. Yeah, let me leave the difference next time. So next time I will show you some simple examples to tell you the difference. These two orders, quite different when you do comparison. So you should be aware of the difference. Yeah. Otherwise, you may get it wrong. Okay? If you use your intuition to understand the order, sometimes you may get it wrong. Yeah. All right, I'll leave that question next time. Yeah. All right, yeah. That's it. Yeah.